All right, so we're live now, and this is exciting. So we're here to discuss an active software supply chain campaign that's going on right now. So if you're just joining us, welcome to the stream. We're going to be talking about this active campaign that we're calling Sandworm Mode, which is a Shai-Hulud style NPM worm that hijacks CI workflows and poisons AI toolchains. But we're going to wait a sec to actually get into all the details. And before we do that, let's just do some quick introductions for the folks that are tuning in, so you know who you're listening to. So I'm Faraz. I'm the CEO and founder of Socket. I spent a lot of time in the open source world before starting Socket. Wrote a bunch of open source packages in the NPM and JavaScript world. And those are today downloaded about 1 billion times per month. So I'm in your software supply chain somewhere, is like what I like to say. Now trying to help protect that supply chain for folks over at Socket. And I'll turn it over now to Doug, our VP of Customer Engineering at Socket.
Yeah, excited to be chatting. I've been in security now for about 20 years, working at a bunch of different companies like IBM, BigFix, Okta, and a few others. Co-founded my company in the past and have worked with all of the Fortune 500 over the last 20 years. So it's been a journey.
Why don't we go next to Ahmed?
Hey everyone, Ahmed Nasser here, CTO at Socket and previously CTO at NPM. Like Doug, I've been in the security/open source space for the past, I would say, 10 years. Obviously, a lot of different campaigns and things that I've seen over my time at NPM, but also recently here at Socket. Happy to share any context as well and what we're seeing and how we're dealing with it. And I guess I'll pass it on to Peter next.
Hi. Yeah, I'm Peter. I've been in the JavaScript world mostly for the past 15 years. Not as much in security, but it's been an interesting past year or two. Yeah, I work for the threat intelligence team at Socket. So I'm an engineer there. I help the researchers do their work, and I love obfuscation and deobfuscation, and that's kind of how I got into this.
Awesome. And then finally, we'll turn it over to Shep at Cloudflare.
All right, thank you very much. Yeah, so my name is Doug Shepard, but because, as we know, there can only be one Doug on the call, I'm going to go by Shep here today. And my background, I was at a national security agency for many years, specifically chasing bad actors, nation-state actors. And now I'm currently at Cloudflare, and I'm currently leading Cloud Force One React, which is our external-facing incident response and threat mitigation team.
That's amazing. We have an all-star crew here today, and so what we're going to be discussing is this supply chain attack that Socket started reporting on earlier this morning. We've been collaborating with Cloudflare as well as NPM and GitHub to get these attacks under control, and we're going to kind of get into the details here together. So I'll start by kind of turning it over to Ahmed to kind of give us some context on what are we talking about here today? What did we see, and why does this matter?
Yeah, so this will be, I think, the third or fourth iteration of the Shai-Hulud style attacks that we've seen in the past few months. The first one that hit us, and I think came out of a shock of this idea of having like a worm propagate itself across a public registry like NPM. The important part here to think about for anybody who's like not sure what a worm is or not certain like how does this impact your life or impact your business and your work. The automation that is happening behind the scene and the surface area that we're seeing impacted by these malicious actors. We're going to go into a little bit more of the technical details of exactly the how and the what, but I just want to make sure that we understand this is something that's happening across a large ecosystem like NPM, impacting a large surface area of open source developers and maintainers, but also private companies and private engineers working on private projects. So sometimes you hear these news and you see things happen in the public space. You think to yourself, this doesn't impact me, this doesn't impact my team. But when these type of attacks that are very large and very sophisticated start propagating their way, they're not just targeting public packages and putting malicious activities into public packages. They're actually trying to steal private information, steal secrets, steal access to repositories, exfiltrate data. And you might think to yourself that if that's only impacting the open source developer or somebody who's building in the open, there's not much to steal anyways. But when that open source package, when those infected repositories and packages make their way into your code base and inside a company, inside a big organization, this is where the attack starts becoming more damaging. If you imagine, people with malicious intent having access to core infrastructure businesses, companies like banks and telecoms, and gaining access to secrets, gaining access to publish packages inside an organizational context, which is what these worms really rely on, that behavior and that mechanism of being able to self-replicate, the attack surface becomes very big and the impact becomes extremely wide. And again, this is an iteration and a more complex, sophisticated way of what we've seen already from these Shai-Hulud attacks. It's funny that they keep using the same theme and the same name, which kind of doesn't help because we keep finding it. But we'll get into more of the technical details of how this level of this particular iteration of it has built up upon the past iterations and the past attempts that they've done, and combining a bunch of those different mechanics and tactics together to attempt to go wider.
Yeah, it's really interesting seeing the sophistication just over the last couple months dramatically increase.
It's also worth noting it's not the same actors who've been doing this, clearly. We don't really exactly know who or what their motivations are. Obviously, this is all anonymously happening out there. But you can see also people being influenced by each other and trying to one-up each other in these type of attacks, and increasing the complexity a little bit, if you will.
That's right. So now I'd love to kind of let's get into some of the details here. So this was what we saw this morning was an automated NPM worm designed to steal developer and CI secrets, and then use those stolen credentials to spread itself through GitHub repositories. And then interestingly as well, AI tooling. We're starting to see this become more common theme in these attacks. What we found spans at least 19 malicious packages, and they've been published under 2 NPM aliases. And there's been kind of a whole bunch of different interesting things that we've been able to tease apart so far, but we want to emphasize this is a developing story. We're still learning more as we dig into this, but I want to turn it over now to Peter to kind of go through some of the more interesting details of the attack and kind of walk us through what we know about this as it stands right now.
Yeah, thanks. So ultimately, it's a worm, and the worm we caught it early, so it didn't really actually explode into anything, which is why there's only 19 packages. We are pretty sure that these are planted by the attackers, and so these packages were very low downloads, maybe even no downloads, and just automated tools that downloaded them. The interesting part about that is that there's many of those. Like there's a lot of those low download malware sort of things. They're not all malware. Like there's a lot of pen testing, but this one stood out because it was doing telemetry. It was checking how many people were actually downloading it, and you don't really see it that often. And so as I dug into it, I saw that earlier versions of that package were actually trying to do a large obfuscated payload. That's even less common, so that piqued my interest. And so I deobfuscated it, and as I was going through it, for one, I saw a lot of interesting things for a package that has like 0 downloads. And the other part is that the keyword sandworm stood out, like in caps, so it actually stood out. And so it kind of, we were kind of waiting for the next Shai-Hulud, I suppose, maybe kind of expecting it over Christmas. And so I was kind of triggered, I suppose. And so I dug into it. We then deobfuscated the second stage. So like this, no, wait, let me just step back a little bit. So there's 23 packages over 2 accounts. About 19 of them contained the package, and then some of the other packages had transitive dependencies on those packages. And so the various different packages had different ways of encoding it, which was interesting as well. They had the same, they had the same payload, but they had different ways of encoding it. And so we decoded it. Some required like multiple levels, but once you see that the hash is the same, the result is the same, so you don't really have to decode the rest either. The worm itself, I guess we should just describe how that worm works. So the worm starts basically dormant. It will, doesn't start dormant. It will start to harvest the most interesting stuff for the attacker, which is crypto keys, NPM tokens, a few other things like low-hanging fruit that's easy to grasp, to grab, easy to transmit, and has low risk of breaking. They will try to, or they were trying to emit that very quickly through a Cloudflare worker, and then there will be a gate that would take 2 up to 4 days, I think, depending on, there was like a little jiggle. And then once the gate was open, it would collect a whole bunch of data, and then it would decode a stage 2. And the stage 2 may actually be the more interesting part, because it had like 6 or 7 different ways of exfiltrating, as well as a whole bunch of replication. So, for example, it would start by trying to, I think it starts by trying to look at your GitHub. So it would use your Git token, and then it would try to infest all the repositories and inject the code into, well, each repository where it could, with various means, by various means. Then it would go to your NPM. It would actually look at all the packages that you own, up to 100, and then it would order them by popularity and age, and sort of like determine which ones were most interesting. And then it would infect all those packages and try to republish them. Let's see, top of my head. Yeah, I don't know. It would then, of course, try to exfiltrate that data. So the data that was gathered in stage 1 would then be sent, and it would be exfiltrated through GitHub. So they would create a private repository in GitHub and store all the data there in very like developer terms. So all the name before Shai-Hulud 1 and 2, they had a very recognizable and easily fetchable repository name, but this time they used a set of like random developer keywords so that they would fly under the radar. As well as the repository would be private, which is kind of strange to me, because even though it was private, having all your repositories updated with like a payload that kind of like lights all the Christmas bells, right? So I'm not entirely sure, but and then by exfiltrating the secret key, the GitHub token, they would be able to access that private repository and then exfiltrate it that way. Let's see, they had fallbacks as well. So like if the exfiltration failed, then they would try to do a DNS query. So they would set up 2 top-level domains, and then send the data to those top-level domains through DNS queries. That was a very interesting one. I haven't seen that one on the JS level before, or at least not in the JS attack before. And then the other one, of course, was Git hooks. So they would try to install Git hooks so that they would, well, basically the worm would stay alive and try to still exfiltrate stuff. They would, let's see, they had an SSH fallback. So like they would, if they couldn't use the GitHub API key, they would try to use your CLI to just try to git push, git pull, git push, and update your repositories that way. They had an AI part of it. So like the AI part of it, it would try to gather a whole bunch of interesting AI keys from all the popular CLI frameworks and even some lesser popular AI frameworks. They would set up a local, so they would try to leverage your local AI tools as well, stuff like Olama and a whole range of those kinds of tools. And they would set up a local MCP server to try and automate certain things. I'm not entirely sure how far that one went. We didn't really dig into that part too much, or at least we haven't had a chance to.
The interesting part about that, I think, is just seeing how there's been more attacks lately that have been like using the AI tools that are on your system as like kind of a way to, I guess, do their dirty work. And so sometimes, we're not looking at actual attacker code. We're looking at prompts, right? And prompts that are asking your AI assistant to do things like read your SSH keys, read your npm-rc file, your environment variables, and then send them out to an attacker. So it's like kind of almost like living off the land, but with AI tools. I think it's super interesting. It's going to completely kind of bypass a typical like endpoint protection that folks might be using looking for code execution, because it's just using your Claude that you're already allowed to use. So, or whatever tool. I'm not picking on Claude. they're all equally affected. Super interesting. Yeah, go ahead.
Yeah, the other interesting thing is it exposes, like what we saw in the previous versions of Shai-Hulud, is that it exposes areas that are normally kind of like blind for most tools. So that's things like in GitHub Actions or other automation. We always assume that everybody has a lock file or something like that in place. But then we find out, oh, no, we have npm install a certain package. That's just kind of bypassing most of the ways that you're doing detection historically. So this is part of the reason why Shai-Hulud version 1 was so successful, is because, hey, there was all of these gaps, in addition to not like pinning your versions of your actions to commit hashes versus versions and things like that. So it's really just kind of exposed a lot of the frailty, I think, in the open source supply chain arena.
Yeah, I think it would be good now to maybe spend a minute talking about so we're talking about an attack, right? What's the kind of current state of things? Like, are these packages still live? What have we done since we discovered this to kind of take steps to protect the community? Maybe we can let's see, maybe Ahmed can lead that part, and we can bring in Shep to talk about the Cloudflare angle.
Yeah, so from our end, like as soon as we kind of surface these detections and we realize there's something big happening here, having seen how this kind of proliferated quickly in the past and how widespread it did in the past, again, different actors potentially, but the same pattern here, we wanted to take action really fast. So the first thing we did was reach out to the NPM team, reach out to the GitHub team, let them know, here are some packages that we found that are clearly malicious. It's not fully activated as a campaign yet, but taking it down was obviously the very first step. At the same time, the GitHub action that was used for kind of the backdooring of all these publishing and surfaced that to them as well. Whatever we found in context of the code that was going to attempt to steal and exfiltrate your data and pushing it to GitHub repos, that's a pattern we've seen before. We gave them all that context. At the same time, we reached out to Shep at Cloudflare because they were also relying on some sophisticated ways of looking at not just using workers to ingest data, but also potentially trying to deploy the data that they were stealing across different domains and different randomly generated domain names across multiple different TLDs as well. So again, collaborating with Shep on making sure that at least that account was taken down from a Cloudflare, probably using a free account there, but also, I'm sure on Shep on your end, you have detections to make sure that this type of stuff is going to be signaled early the next time they attempt to do something similar. So yeah, from our perspective, like just looking to protect the community, looking to protect the ecosystem, taking these things down as fast as possible is the most important and the very first step we wanted to take. Obviously, from us here at Socket, we can only raise the flag and ask our partners to help and make sure that the ecosystems are responding, and they did, which is great. And then, of course, from our perspective as well, like as we look at our customers, our users, people who consume our data, we make sure that they're aware as well and they have the context of, hey, somebody out there is trying to make another large campaign, so shore up your defenses, make sure everything is being monitored. This one was taken down, but it's important for us as a community, but also as an ecosystem and as individual developers or part of bigger teams as well, to keep our guard up. Because now that we've taken it down, they know where we're onto them early. So the next attack, the next attempt, they might try different things. So we should all be diligent and aware.
Yeah, so the part of being in the role that I'm in is you never know how your day is going to go, right? So whenever I get a call around noon my time that there's a sophisticated like a new worm that's potentially using our infrastructure, that's very concerning, And so Cloudflare, actions malicious content as it's discovered, and this clearly violates our terms of service. So we worked hand in hand with our trust and safety team. And within minutes of being notified of this, clearly, was malicious, and we brought it down. What I really have to commend the Socket team on is that, as we're going back through and doing our investigation into this worker that was being abused by the threat actor, we saw very limited activity, which means that it got caught very early, and it sort of corroborates everything that you're hearing here from the Socket team. Sort of indicating that the attack was at the beginning of the life cycle and hadn't, spread through it as bad as previous versions of Shai-Hulud had. It could, because at the end of the day, like these threat actors are mission driven. They're motivated by efficiency, data, and economics, and the more cost you can impose into them stealing data or an economic benefit, you're reducing their efficiency. So, threat actors like to use any cloud service, any provider that they can to accomplish their objective. And in this case, Socket team did a great job in providing us indicators of compromise. That's the other great thing, is like, you don't expect to get this call at 12 o'clock, and then you don't expect by 12:06 to then have all the indicators of compromise you need to action something as quickly. Normally, you have to dig into it a lot and see what's going on. So we definitely commend the Socket team for both identifying this, but also providing very thorough analysis so that we could immediately action this with our trust and safety team. Because, a threat actor is going to use any tool at their disposal to carry out an attack. And in this case, we wanted to make sure that we were not participating in, any of that activity.
Yeah, so I think maybe now we should spend some time I just want to get more of an idea of I think we should share with folks, just some of the things we saw in this attack and kind of how common they are or uncommon they are. What was unique about this? What's kind of like the stuff we see all the time in terms of people using NPM or using Cloudflare, using these different kind of resources to do their attacks. Maybe we just start with something really simple, like how common are typo squats and obfuscated files? Maybe Doug, you can take this one. You're muted. Doug, unmute.
Yeah.
Sorry, completely forgot I was on mute. Yeah, it's pretty common. We see it all the time. Like, this is the number one thing that I talk to customers about when we talk about malware. People are just like, oh, typo squats, that's a thing. And I think it's pretty well known in the industry. It's also such an easy thing to do. Like, amount of times I mistype our company name because the R and T is next to each other when I'm trying to type in a CLI command. It's ridiculously easy to do. So picking up those typo squats, even when you don't really think about it, with just a number in between, and kind of putting a 1 in instead of a L or something like that, are stuff that's going to happen. It's also, I know for us, you've talked about like slop squatting before as well. The kind of AI age where code's being generated, if you realize the patterns that AI is generating names for, sometimes if you have a poorly written prompt, it will generate something with a fake package name because it thinks that's what you want. And so now if I know those patterns, and like something I've realized is if you ask AI to create you a tool that supports an API key, it's going to be company name _ API _ key every single time. So that's like one vector that you can attack. And you know what? It's going to do a similar thing for package naming. Like, I don't know what to name my package. What should I name it? It's probably going to be company name and then like a couple keywords after that. So I would say like AI coding is making it easier to do typo squatting or like manifest confusion type attacks. And I see this all the time when I'm talking to customers. It's a concern. It's something that we often recommend. Like, hey, I noticed you don't actually have a namespace reserved on PyPy, on NPM, on all of these kind of platforms. It's a simple security measure, but it's missed, and it just really opens the doors for these attacks.
What really got me was looking at this attack. Like the one of the typo squats they did was taking advantage of OpenClaw and the popularity of OpenClaw right now. And so the name they registered was OpenCraw, like CRAW, and that's actually kind of an easy one to mistype because it almost sounds the same, the craw and claw. So interesting to see that. But I want to know now, kind of like, what point did we realize this wasn't just a normal typo squat? Because we do see these somewhat frequently on Socket. We are this is one of the things that we detect. One of the alerts that we support is the possible typo squat detection. But like, Peter, maybe kind of, since you were the first to find this, like, when did you realize this wasn't just sort of a normal typo squat package? What signaled it to you?
It's very uncommon for typo squat packages to actually do telemetry. They don't usually check whether or not the package is actually downloaded. Either the typo squad is trying to do pen testing or it's trying to do actual bad stuff. But in this case, it was just telemetry, which was curious. And then seeing the fact that it's a large payload in an earlier version is also very uncommon. And of course, after deobfuscating the first layer, it was very clear that this wasn't just a normal, simple type squad.
Mm-hmm. So why do we call it sandworm mode? Are we calling it that?
Because the initial version that I found seems to be a development version, which is kind of curious, but it's a development version of the worm, whereas the later packages all had more of like a production ready version, which had all the URLs. And so that, well, both versions actually have environmental variables, and their one of the environmental variables was sandworm underscore mode in all caps, and so that kind of stuck.
Got it. And so in terms of the kind of the way this differs from the other Shai-Huluds, like why are we calling this? Why are we saying that this is sort of in a Shai-Hulud style? What about what you saw when you deobfuscated it ties it to that previous campaign that obviously a lot of people have heard about at this point?
Yeah, I actually was also one of the engineers that worked on that piece, and one of the things that stood out for me was the fact that they exfiltrated through GitHub rather than some random domain. So the fact that this worm was also doing that immediately stood out to me and was like, okay, that's curious. Of course, the fact that it's sandworm, having seen the Dune movies and the reference, I kind of knew that Shai-Hulud is actually a sandworm. And then the complexity and the sophistication of the whole thing, I don't know, kind of pieced together that this wasn't just an ordinary sort of thing. And it had all the intricate little, I don't know, signs of the next Shai-Hulud, which, like I said, we were kind of expecting.
Mm-hmm. Now, one thing I noticed about the attack design was that the malware seems to, it steals crypto keys immediately when it runs in the first stage. But then for the second stage, it has like a 48-hour delay, or it may be 48 hours at least, and potentially longer with some jitter. Why do we think that the malware would want to steal crypto keys immediately, but then delay everything else? If the point of the delay is to sort of hide from detection and hide from different sandboxes that it could be running in, what do you think that's about?
That's a good question. The reason I think ultimately is that crypto is, of course, the most valuable part of the whole thing. If they have crypto keys, they can drain the wallets and they can immediately get that money. And ultimately, the money is what they're after. All the rest, the more noise they make on a machine or on a computer or in a CI, the more likely it is that somebody else picks it up. And as we've seen in the previous attacks, as soon as companies like us are onto that attack, everybody will be on the attack. And then the attack will falter very quickly. And so they know that they don't have that much time to actually do their damage.
That's exactly right. And by stealing the crypto keys, you establish sort of an inferred persistence, right? So even if you get detected and, even if there's this report and everything else, if you have enough crypto keys, there's going to be somebody that doesn't hear about it, somebody that doesn't rotate it. And so they get to continue to persist in there with, stealing the crypto material first.
And it will be a stepstone for the next attack as well, right? Because all the authentication keys that they steal now might be used, weaponized for the next attack. So
So does this mean that they just because unfortunately crypto is now an overloaded word? We don't know if it's cryptography or if it's cryptocurrency, and it'll always be cryptography in my mind. I'm just saying. But so are we talking here about actual like wallet keys for cryptocurrency? Or are we talking about generally like it steals all kinds of different key material? Because I know at the later stages, I believe it was doing that. But does it also do that in this first stage?
The first stage is actually about trying to get the money, the wallets type of crypto for sure. That's what they're seem to be prioritizing, and then after the gate they will try to get everything.
Got it. So do you think, what do we think right now about this attack? Does it look like it was a sort of a smash and grab, like just let's get these crypto keys, or was there something more sophisticated here? Because I'm seeing a bit of both pieces. I'm seeing the sort of grab the crypto keys, but then we're also seeing this like quite a bit of sophistication, the second stage, the delays, and then just so many like different steps that you went over earlier, Peter. Like, what do we think we know right now about what we've seen so far?
Honestly, it's guesswork. So we caught it early, meaning that it never really came to pass. We don't know how large the actual deployment would have been. Maybe these type of squads were the actual deployment, and they were trying to just bait people to slowly, get into it. Because this worm is very aggressive. So once it would have started to replicate itself, it would have actually replicated very, very aggressively, and I think would have gotten pretty far. But the fact that they haven't, we don't know if this was the final version. Maybe this was just a trial run, and maybe they will still deploy this under slightly differently tweaked sort of parameters. Mm-hmm. It's all guesswork for me, at least.
Yeah, these things can spread super fast, as we saw in the prior Shai-Hulud variants. We had, I think the largest one had in the thousands of packages within a few hours, just because once you start getting folks running npm install on a popular package, it affects everybody. These supply chains today are so deep, and these packages are so foundational. Some of them, right? They're just used by everybody. You get into like a library like Express or Lodash or just name your favorite. I guess Lodash is a bad example. It doesn't have any dependencies, but packages that are widely used in these ecosystems, and then very quickly you have really like a large blast radius of people that could install it, and then given that it has a worm behavior, right, it just spreads super fast. So super interesting to see that.
I was going to say as well, because we've seen like in the source code of the different packages, they clearly were still experimenting with different mechanisms. Like there were some dead branches of the code that were still sitting there. So I think the fact that we caught it early, doesn't necessarily answer the question of what is their intent or how they're going to evolve it next. But clearly, this is an ongoing type of experimentation that they're running. And who knows? Like maybe they still had more things to add, more things to do. But then we got it early and we got it shut down. So it's interesting to see where they go from here and what they try to attempt next. But to your point, for us, like being in the critical path in a lot of these popular packages or type of squatting themselves into there, it could spread very, very fast.
Yeah. So let's maybe touch on like how we worked with npm, GitHub, and Cloudflare to react to the attacks. Like how quickly did this come together, especially with the Cloudflare team? I guess Doug or Shep mentioned earlier, kind of a little bit about the way we were able to work together. But I'm curious to learn a little bit more too about the npm and GitHub piece, and like generally how we work with partners on trying to stop these threats.
Yeah, so I can reference more detail what we talked about earlier, which is just knowing the source code of the packages. It's not enough just to look at them and see that it's a type of squad, and there's different kind of behaviors in different packages that we've noticed, and evolution, as we were saying, of how they're trying to make this more sophisticated. That's where kind of like the socket system kind of shines in terms of being able to pull that information as soon as it's published, and then thanks to Peter doing the deep dive on it, surface that early. So when we do go to our partners like npm, or in this case it was npm, but in any other context, like be any other package registry, we're able to give them straight into like, here's the files, here's the lines that are actually doing the bad things, here's the package names, here's all the different versions. And by the way, in this example, there were actually previous versions published of these packages that were not malicious. They didn't have anything bad in them. It just, the name confusion was the initial step. So it's not enough to just see something being published and has a name that's very similar to something else. because they had a couple of versions published that were normal, and then all of a sudden introduced the malicious code. So that's kind of the first step to share with ecosystems like NPM and say, look, this is exactly where the issue is, which helps them also cut through a lot of the process. And like as Shep was saying earlier, having these indicators of compromise make the process smoother and cleaner for everybody, because everybody has their own internal processes and tools to deal with these things. So kind of like the important part is sharing the compromise indicators, getting them straight and shortcut them to seeing where the issues are. But also from the GitHub aspect, because like as Peter said, like typically these attacks have, or historically they've used like the publishing to creating and publishing public GitHub repos and exfiltrating data through them. Again, we see that in the code. We see the patterns of the naming schemas, all these type of things, and sharing that out as well to the GitHub team. Specifically in this case, it was like relying more on the workers, which is why we are working with Shep on it. But we've seen like some of that examples in the code as well, and they have the GitHub action that they were relying on. So again, that's another indicator. And one of the main things we also like nudge our friends and partners at GitHub at is let's make sure that GitHub action never actually ran in any customer context, because we can only see what's in the public repos, right? Like we can all go and search and look for that in our GitHub search that we have access to, but that's only the public information. What we don't know is did that make its way into any internal company repositories or organization and somehow ran inside there, because then that's something obviously we can't see ourselves. So giving that like upfront context and helping kind of shortcut the homework that the teams have to do, kind of accelerate the action. Of course, the action here is take it down, ban the user account. Of course, they were using an anonymous email address. I think it was I forgot what the email was. Yeah, there you go. And we would anybody in that scenario would block that email address, but there's no further tracing beyond that, right? Because it's anonymous. There's no way to actually identify who the individual or individuals are in this scenario. But now that we all have those patterns, we can keep an eye out for them, right? We at Socket obviously do this from the outside in, and then ecosystems like NPM, PyPy, Ruby Gems, and so on have their own kind of internal kind of monitors as well, and we're happy to contribute to all of that. And again, from the Cloudflare perspective, ultimately there's nothing simpler than just launching a service and just ingest some data. There's very limited kind of scenarios that you can monitor for that. In fact, if you're building on Cloudflare workers, that's kind of an expected behavior. So I'm curious, Shep, from your perspective, how do you look for these malicious intent as opposed to just a HTTP endpoint that's accepting a post request? Maybe you can share a little bit of how do you look for these type of patterns as well?
Absolutely. In this particular case, you're right. Like Cloudflare workers inherently are just doing this activity at some scale, but specifically looking for heuristics associated with attacks like this. There's always going to be differences in like volume. There's going to be like differences in sign up, in the behavior of the account. So, being able to take indicators that clearly show malicious activity and being able to look across the estate for that is very useful.
I'm curious, I don't know if this is something you can share, but like how often are you seeing worm activity using I think the worm, at least from our perspective, from the public package kind of registry side and open source dependency side, this idea of a worm, it's like it's an idea that's been around for a while, but it almost seems like every interesting attack in the last 6 to 9 months has had a worm component to it. And so it's kind of like a newer thing that we're seeing on the open source supply chain side. I'm curious, like if you see it, have seen different on your side, Shep, from just kind of like how do folks use abuse Cloudflare infrastructure, for the kind of things you're seeing.
Yeah, I think that's really more of a function of, I'll call it malware vibe coding. I think the cost has never been lower to launch these sorts of attacks, whereas 15 years ago building a worm might have required a lot of sophistication and business logic inside of the malware. Now you can just sort of say, hey, LLM, I'd very much like to do this thing, and it doesn't really take a lot of programming chops to do that. So, I would say the function of seeing more worms in the industry, which I agree. I've seen that certainly in the last year, the uptick in worm activity. It's really going to be more about how you can describe what the end goal you want when you're vibe coding that malware, because it's going to say, hey, we can do a C2 here. We can use this cloud provider. We can use this infrastructure. We can use this DigitalOcean. So it allows malware authors to know less and be way more creative, because the AI is sort of connecting the dots of like, okay, we can establish C2 this way, we can exfil this way. So I think that is, less a function of any particular provider and more of just the barrier for entry for developing these sophisticated autonomous attacks being so incredibly low now.
Mm-hmm.
So the funny thing for me is I feel like we finally realized the 90s hackers movie with the worm there, it was stealing financial from the banks directly as opposed to cryptocurrency. But hey, we're now in the era of worms stealing cryptocurrency and doing other things.
Absolutely. And no one here better develop the Office Space worm where it just takes a penny from everybody, right?
Yeah, it's a great movie. I rewatched it recently. It's still just as good as it was always. So what do we think? I mean, maybe we can kind of start as we get close to wrapping here. Like, what do you think this campaign tells us about 2026 and the supply chain threats that we think we're going to see as the year unfolds?
You want me to start?
Yeah, anyone can go. I mean, I have my thoughts. But yeah, go ahead, Shep.
I mean, just like the rise of AI vibe coding, people are also realizing like the way to spread malware and have your campaign be the most successful isn't to target a specific company or even a specific vertical. It's really to see if you can hook into one of these libraries or packages. You're saying 1 billion downloads. If I can hit, just 1% of that, I win as a malware author. And so, of course, because they're motivated by data and economics and access, they're going to naturally gravitate towards that. And again, because they have AI to assist them with it, I think, again, the barrier for entry for doing these kinds of attacks has never been lower. So it certainly should make the industry pause and consider, what safeguards can be put in place to, protect these upstream dependencies that everybody has, every single company, everybody on the planet.
Yeah, absolutely. Yeah, that's why I always say it's not really a question of if you'll be affected by a dependency supply chain attack. It's a question of when, because the dependency trees are just so deep. They're so deep. The trend in the last 10 years has also been for dependencies to get smaller in size and more numerous. And so the number of people that you trust has gone up by quite a lot. This has mostly been led by NPM, but you even see newer ecosystems like Rust kind of following in a similar model of a lot of tiny dependencies and a lot of different diffuse trust. So yeah, and you great point, Shep, on like these sort of single points of failure, sort of really important nodes in the network. There are a lot of those. There's someone on the socket team, I won't name him just in case he doesn't want me to name him, but he's individually responsible for 13% of all NPM download traffic by himself. And so like if that account ever gets popped, it's going to be an interesting day in the industry. I think he's very good about his security, so that will hopefully never happen. But there's quite a few of these folks out there.
I think the other interesting part here is that in this attack, it looks like they were trying to take two angles. So you're not just being attacked on the NPM side, but you're also being attacked on the GitHub Actions side, which means that you may have been, done your best with all the NPM publishing stuff, but then your AI starts running this random GitHub action, which looks innocuous and has no faults and no errors, and suddenly you're compromised.
Mm-hmm.
So it's not just one ecosystem anymore. It's a whole bunch of ecosystems. CloudBot plus NPM plus GitHub Actions plus whoever else. Yeah.
I think that's one of the main takeaways as well, which is like, don't get distracted by the cryptocurrency stealing thing at the upfront. That's clearly like obviously monetary driven attempt to get something out, but the fact that the attack surface now includes all these touch points, like Peter said, especially using whatever's they have access to for your local environment, because historically and in the past, people would care more about protecting their production environment, right? Make sure that there's no malware in production. Make sure nobody has access to the business database or the product database and so on. But now you have all these tools running on your machine. You have a lot of these AI automation tools that are co-pilot agents that are running on your laptops, on your company devices. Presumably, there's a lot of protections around these things, but also they're acting as you. So those protections start to become less and less effective. And those tools, by the way, they probably have MCP servers connecting to databases. They probably have skills that are telling them how to access some critical company information, or how to access critical company resources, or so on and so forth, because that's the whole purpose of these tools on your endpoint devices, on your machines, is to make you more productive. And therefore, they probably have access to a lot of things. So like the attack targets are now shifting to leverage these tools and leverage the developer machine way more than historically, as we all been seen in the past few months. They're targeting those developers as opposed to targeting a production environment or trying to get a backdoor into a live API so that they can steal your data. The weak point is now you, the engineer, the developer, your laptop, no longer the infrastructure or the production environment.
The only thing I would add on to there is I get some companies that say, oh, we don't use open source. I'm like, oh, do you use any tools that use Nginx or HA proxy or any of these ones? Like, well, yes. I'm like, you use open source. You might not directly use it in your source code. And this is like that wide range attack profile. I can't think of any organization in some way, shape, or form that doesn't use open source, even if they don't think that they are using open source because they're not using it in their first party code. And so all it takes is one update from a vendor that you have that has something like that. And now that's in your network. And they say, oh, I'm in Kubernetes, a separation of control. Well, no, those containers actually have elevated permissions. And now I can go east-west and do my exfiltration that way. Working at a web application firewall for a while, I saw a lot of that. So it's a really hard problem to solve now. And something that with Zain Lackey, that when I was working with him there, he always said it was security in layers. Like, that's what you have to do. It's like there is no silver bullet, which is what everybody's always asking for. It's what are the layers of protection, especially in this new era of AI, that will help keep us the most secure we can be.
And just
if someone says they're not using open source, then I'm even more concerned for their security posture.
Yeah.
Yeah, they're probably using open source and don't realize it, because I'm so skeptical of that claim.
It doesn't exist.
Yeah, exactly. Well, I'm going to put up the URL on the screen of the blog post that goes into all the technical details. You can see it down there. It's tinyurl.com/sandworm-mode. If you visit that link, you can get all the details about the attack, and we'll continue to update that post as we learn more. But yeah, this is been really fun conversation to have, and we pulled it together here kind of quickly. I want to thank everybody, especially Shep, for being so up to do this on short notice, and also, of course, thank you for being so quick to respond and help protect the open source community and ecosystem. Super important to do that, and it's a big community effort from a lot of different companies and a lot of different people that care. So. With that, unless anyone has any kind of final words, this has been awesome to do, and we'll continue to update the post with anything new we learn. Socket has put in place blocks for these packages. So for anyone using Socket, you can rest assured that you're in good shape. But if anyone has questions about anything relating to this attack, feel free to reach out. I'll just drop my email in case anybody wants to email me. I always love to talk about this stuff. So my email is feroz@socket.dev if anybody wants to get in touch. And I can forward along to the rest of the Socket team. And Shep, I don't know if you want to share maybe where people can find you online if they want to get in touch.
Yeah, if people feel they've been affected by a similar incident, reach my team at cloudforce1@cloudflare.com.
Cool. All right. Well, thank you all for your time, and thanks for all of our viewers for tuning in, and hope you had fun learning about this attack, and see you next time.
Thank you.